Alright, today we are graphing more of our exponential functions. Who remembers kind of what our graphs look like? Are they straight lines, parabolas? What are they? They look like that. They got a little curve. And we get closer to lines. What?
Always going
Flat
up.
line?
No. The end part of it.
The end part of it. Oh, going straight up?
Yeah.
Whatever. Alright. It says we're going to graph y equals negative 0.5 times 5 to the x power. So what we have is our parent function, okay? Remember we have this a b to the x. The b to the x power is always your parent function, okay? So in this instance, we would have 5 to the x power. That's our parent function, okay? Just like yesterday, in order to graph, we're going to make tables. Yay. What do I want to pick for my x's? What did we choose yesterday?
We chose
Biggest number we can.
Yeah, easy numbers. -2, -1, 0, 1, 2. If I take 5 to the negative second power, I get what? No. What does the negative do? Yeah, put a 1 over it. 5 squared, 25. How about if I plug a -1 in?
1/5.
1/5. 0 is always
0.
1.
1. If I put a 1 in, if I put a 2 in, 5. Okay. Are we okay through there? Okay. What we're going to do now is take our y values times what's out front. Okay? So I'm going to multiply only y values times -0.5. So x values stay the same. We got calculators? Okay, get them out. If you don't have one, grab one. What is 1/25 times -0.5? Can I get a decimal of that? That seems easier. -0.02. Okay. How about if I take 1/5 times -0.5?
I'm confused.
What?
So why are we doing the second graph and how are we doing
The second table?
that? Second table.
So our first table is just 5 to the x power, but our function is take that times -0.5.
Okay.
So in order to graph our whole function, we need this red table. And we're just taking the y values times the a value that's out front. Okay? If I take 1 times -0.5, I get -0.5. If I take 5 times -0.5, -2.5. And if I take 25 times -0.5, -12.5. Okay. Questions there? Okay. All we're doing now is plotting those points. Yes, some of them are hard to plot. Do your best, okay? -2 is like pretty much at 0, but a little bit down. -1, same thing. 0 half, 1 -2.5, and 2 goes way down. So my line looks something like that. it says, how does the graph compare to my parent function? Well, my parent function we know looks something like that, right? My parent function.
Times -0.5.
Well, yeah, it's times by -0.5, but graphically what's different?
Negative.
It's flipped. Who remembers what this negative does?
Reverse. 1 over. 1 over something.
That's our exponent. This negative reflects it over our x-axis. Which is why instead of going up, it goes down. Okay, that's what the negative part does. What does that 0.5 do? Yeah, compresses by a factor of 0.5. Remember, stretch if it's bigger than 1, compress if it's a fraction, or between 0 and 1. Okay? Leave it up with parabolas, with our absolute value functions. Last thing it says is state the domain. Domain is my x's. Can I plug anything in for x and get an answer? No? If I put 2,000,001, could I take 5 to the 2,000,001 power and times it by -0.5 and get an answer? Yeah, it's going to be crazy, but could I do it? Could I do negative 2,000,001?
Sure.
Yeah. So my domain is all reals. My range is my y's. Looking at my red function, so this red one is that y equals -0.5 times 5 to the x power. That's the function I'm talking about. Is there any restriction on what my y's are? Or can they be anything? Can't be positive, yeah. This line we talked about yesterday, it gets closer and closer and closer and closer to 0, but does it ever touch it? No. Does it ever go above and become positive? No. So for our range, we say y has to be less than 0. Not even equal to, just less than. Okay. Questions? Domain x, range y. Okay, let's try another one. I have my function 4 y equals 4 to the x plus 2 power. Guesses on what do you think is going to happen? How's it going to be different? Well, first off, what's my parent function? X plus 2. 4 to the x power. Yeah, I want an exponent function.
It's going to be up to.
Up to? Okay, any other guesses? Left to? Tell me the difference. How did I know in parabolas and absolute values if it was left or up? If it's in the parentheses or not. If it's in the parentheses, it went left or right, yeah. So what do you think is going to happen? Left. If it were going to go up to, it would be down, like you know how we got 4 to the x plus 2? It would be down like a regular number, not an exponent, if it was going to go up to. Okay? But since this is by our x, we are going to go left or right? Left too, because it's backwards. Okay. To graph, we're going to plot, or I'm sorry, not plot, but we are going to take our table and do our parent function. Okay, we said parent function was 4 to the x power. What do I want to choose again for my x's? Yep, -2, -1, 0, 1, 2. First one I get is 1/16. What's the next one? Next one. Next one. Next one. Does everyone know how the girls are getting those numbers? Did you say no? Okay. So my function is 4 to the x power, right? So if I plug -2 in there, 4 to the -2 will negative exponents make a 1 over. 4 squared is 16, so 1 over 16. Does that make sense, Kate? Other questions about how they're getting those numbers?
So you just forget about the x, like the 2 for the +2, you just do 4x.
For now. Okay. Okay. Easiest thing to do. Plot those points, okay? So -2 again. No, it's not gonna be perfect. We're just gonna get close. And then I'm going to dash it because, like Sierra said, that's not our complete function that we want. Okay, that's just our parent function. I went negative. I'm sorry. I'm sorry. My bad. So this is our parent. Y equals 4 to the x power. I'm sorry. Okay. Then all we're going to do is take each point that we plotted and move it where? Left 2. So 0, -1, move it left 2. 1, 4, move it left 2. Our baby ones, move it left 2. So that the graph we have looks something like that. Again, I don't expect perfection. I can't get it to be perfect. My line, no, it shouldn't go up a little bit, but I feel like we know what's going on, right? As long as you don't expect perfect from me, I don't expect perfect from you. We're not done, go back. It says state the domain and range. Domain, can I choose any x and get an answer? So what's my domain? All reals. Do I have any restrictions on my y's? Can it equal 0?
No.
Okay, so y is greater than 0. Okay, questions there? Okay, this one. We got a lot going on in this one. Tell me how it's going to be. Well, first off, what's my parent function? How do I know 2? Why is it -3? Yeah, the 2 is the only thing that's getting taken to the power of x minus 1. -3 is not getting taken to our exponent, okay? So my parent function is y equals 2 to the x power. Okay. Let's go just left to right. Looking at my parent 2 to the x and looking at the function that I have, -3, 2 to the x minus 1 plus 3, what does the negative part do? Over my x. Yep. So the first thing I'm going to do is reflect over, you can just say x. I know you mean x-axis. That's fine with me. What does the 3 next to the negative do? Stretch by 3. Okay, remember, you're not stretching by -3. The negative is our reflect part. Okay? What's that -1 doing? Right one?
Down one,
Right one, down one, which ones?
down one, because signs are right the same.
It's right one.
It's right one, because why?
Because in the last one it was left two.
Because it's by my x. Okay? It's up in my exponent. So I'm going right one, and then what else, Courtney? Up 3. This is my +3. So we got tons of stuff going on. Okay. First thing. Table. Of my parent function. Okay. What do I want to choose for x's? -2, -1, 0, 1, 2. Okay, 1/4. 1/2. Next. Next. That's my parent function, okay? Who's got to guess what I want to do next? Graph it. Why? Yeah, I can reflect and stretch, okay? You can graph it if you want. I personally think we got a lot going on, so the less graphs, the better. If you want to graph it, totally okay. We're going to multiply our y's only by what? -3. So x's are staying the same. But my y's are changing. Decimals, fractions, don't matter to me. If I take 1/4 times -3, what do I get? -3/4. If I take 1/2 times -3. -1.5. -1.5, however you want to say it. If I take 1 times -3. -3. If I take 2 times -3. -6. If I take 4 times -3. -12. What's the only thing left to do? Right one, up 3, okay? The easiest way to go left, right, up, down is to have plotted points, okay? I wouldn't mess with adding 1 to your x's, adding 3 to your y's, whatever. I think it's easier just to move points, okay? So that means I'm going to graph these points, my green ones, okay? So -2, -3/4. -1, -1.5. 0, -3. 1, -6, then we go crazy. I'm also going to dash it because it's not my final answer.
Wait, did you graph the green one or the red one?
Great. The red one
Yeah.
would be up. Like that. Okay. You said I had what left to do?
Do I have a range?
Do I have my whole function graph?
Right one.
For each point that I have plotted, move it right 1 up 3. So right 1 up 3. So we got something that looks like that. How do I know if I should cross my 3 or not? This is under my 0, so if I move this line up 3, it should stay under my 3, right?
Yeah.
Okay. Alright, last thing. Domain. All reals, are you sure? Okay. Range. What can my y's be? Less than 2? 3? You guys agree? My blue one, can it go over 3? No. Y has to be less than 3. Okay. Question. Tables, tables, tables. All right. This little box thing is just kind of what we've talked about. If it's a stretch, your number's bigger than 1. Compression between 0 and 1. Reflection is your negative out front. And then moving left and right. So horizontal is your H. Vertical is your K. It's down like a regular big number. Okay. Questions on translations? Even more favorite than graphs are word problems, I know. We just love them so much. It tells me the initial temperature of a cup of coffee is 203 degrees Fahrenheit. An exponential model for the temperature Y of the coffee after X minutes is Y equals 134.5, and then stuff. How long does it take for the coffee to reach a temperature of 100 degrees Fahrenheit? Am I plugging in 100 for X? Why not? What does X stand for? Yeah, X is minutes. Y is the temperature of coffee. So where am I plugging in 100 for? Y. Do you guys agree with that? Let me go on some laps and wake up. So I'm going to put 100 in for Y. So 100 is 134.5 times 0.956 to the X power plus 68. Subtract first. What do you think? Divide first. Make a table, just guess.
Sleep on it.
Do what?
Sleep on it.
Well, that's fine. I can sit here and chill. What do you think we should do first?
Minus 68.
Minus 68. Okay. I know, but no one else says anything. What do I get if I take 100 minus 68? 32. Now what should I do? You agree? Divide? Yeah, it just says yes. Divide by 134.5. What do I get? 4 decimal spots. Do I know how to get the X by itself? What? Gotta start guessing. Oh, you can't square it. Give me a number we want to start with.
-2.
0.2.
You think it's gonna take 0.2 minutes for a 203-degree cup of coffee to calm down to 100 degrees?
Yes.
5.
Heck yeah. If you put it in.
10 minutes. If
7
you throw it
minutes?
up into the
Okay.
air in winter, it'll freeze before it hits the
Where am
ground.
I plugging 10 into? X. Take 0.956 to the 10th power, and what do we get? 0.64. We're way off.
Let's go to 5.
You think it's gonna take less time? Oh my,
So
we
that's
got
only-
guessing
Well,
skills.
37
What's the number after?
hours.
0.2379.
Yeah, that's what
I gotta
want.
get a
Go smaller.
203-degree cup of coffee down to
Go
100
5.
degrees.
20.
5.
Whatever.
35.
Now, why is coffee that hot?
I did 20 and it's
Didn't I see that? 4.
35.
What?
Point
Or-
0.40.
Why is it
Sure,
so
so
hot?
32.
32. Okay, if I put 32 and 0.956 to the 32nd power, what do we get?
0.2369.
So we're only a little bit off.
Let's go to 33.
33.
33 and a half.
So I want to be less than this.
31.
Let's try 31. I feel like we gotta work on our guessing skills. 0.2479. Now we got 0.24 and 0.23.
1.5.
So I get
0.2423.
what?
No.
Really?
Not possible.
31.5.
Not possible. Is it? Wait.
2423.
423.
Which one's closest?
33.
Takes about 32 minutes.
Why is coffee so important?
McDonald's served it.
See?
That's what I said.
From that one case long time ago.
Long time ago. Poor girl got her hot coffee.
And super balance.
Okay. Next up. Calculators. I hope we got them.
Nope.
It says use a calculator to complete the following table. 10 to the first. So 10 is what you're putting in here and here. So take 1 divided by 10. Plus 1 to the 10th power. And what do we get?
1 by 1.
What?
Or 1 and 110. Like that.
To the what power?
If you stick 10 in here, 1 over 10.
2.5937.
Yeah. 2.5.
937.
So 9.4. You take 1 over 10 plus 1 to the 10th power.
Okay, it didn't happen. I just
10 squared is 100. Take 1 over 100 plus 1 to the 100th power.
That is
What'd you get?
2.704.
2.704. 10 to the third is how much?
1,000.
1,000?
No.
Put 1,000 in there. I don't know,
That's
that's what you
wrong.
said.
It's wrong.
What is it? What's 10 to the third? Is it? Okay.
I was trying to make guess.
What do we get?
2.7169.
717. 10 to the fourth.
10,000.
10,000. Plug it in.
$2.718.
2.718. 10 to the fifth. What are we at? 100,000? Put 100,000 in there. What do we get?
2.718.
Guesses on if we put 10 to the 6th in there, what are we gonna get?
Yes.
2.718. So what value, no matter how many zeros I put in, are we approaching? What is the same? 2.718. Guess what? This number is what we call E. Find the E button on your calculator. Find it,
No.
hit it, press equals, and you should get 2.718.
I don't see it. Is it like
Yes. I think I did it.
You have E on exponent.
so right?
Oh, did I do it?
So I just
You just have to hit 1.
like
One.
there. Or
One shift, because it's yellow. So 1 shift in that button. Everybody find E on their calculator? Well, yeah, a lot of times it has an exponent. E helps us compound interest. Yesterday we talked about if it's like annually compounded. This is if it is continuously compounded. Okay? Same sort of equation though. Your principal times E. E is just a number. Okay, you don't ever plug in for E. Okay, R is your rate, T is your time. Let's try one. So suppose you won a contest at the start of 9th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. Let's pause. What's my 3,000 bucks? What? My principal, my initial. Principal is the same as an initial event and principal. Your initial amount that we had yesterday, principal, initial amount, same thing. Is the 5% helpful? Yeah, what is it? My rate. So my rate is 5?
No.
0.05. Good. Okay. Continuing on. It says you start college 4 years later and spend 4 years in college. About how much will be in the account after 4 years of college. So what's my time? T. 4, 8. What do we think? I start college 4 years later, and then spend 4 years in college, and it wants after the 4 years of college. So 4 plus 4 is 8. So my T is 8. Let's plug it all in. Looking for my Y / my A of T, whatever you want to call it. I take my principal P, that 3,000 times E. Notice your R and T are both exponents, so you need to multiply them together first. Okay, so 0.05 times 8. So let's simplify this. What is 8 times 0.05? 4. 0.4? Okay. So we're going to take 3,000 times e to the 0.4. Okay. In your calculator, if you have the ones that look like this, I believe... Okay. If you have ones that look like this, hit your E button and then put 0.4. I don't know why it doesn't make it an exponent, but it is calculating it that way. Okay? So you'll hit in your calculator E and then 0.4. This is what it'll look like. And what do you get when you do it?
Do I get the one shift E or do I just do
do that button, so your shift to get that, and then 0.4.
1.49.
Yeah. Good. So e to the 0.4 is about 1.49. Take it times 3,000 and we'll get our answer. Good. Anybody not able to get this 1.49 with your e?
Where is he?
E is, do you have one of the, okay, let me sketch you. It's on your LN button. You try to shift. Okay.